Stan Jabalisco here to talk a little bit about a couple of pressure sensor devices, both of which are described in this book, Teach Yourself Electricity and Electronics, 5th edition. You'll find this information in chapter 30, and you will find a link to the Amazon page for this book in the description of this video. Two types of pressure sensors that might be used in robots, for example, mobile robots. The first type is called a capacitive pressure sensor. What do we mean by pressure sensor? Well, we mean something that senses pressure, like when something hits it, it'll send out a signal that can tell something to do something. Here's an example. Two metal plates separated by a dielectric foam. This dielectric is insulating, so it doesn't conduct. These two plates, therefore, form a capacitor, which is in parallel with an inductor here, which determines the frequency at which an oscillator circuit works. So when this capacitance changes for any reason, this oscillator frequency will change, sending a signal along to an analog to digital converter, ADC, and then to a microcomputer, which will tell some machine to do something or other. For example, it'll tell, maybe it'll tell your microwave oven to start up, or maybe it'll tell your, who knows, tell your digital camera to start recording the scene inside of your house, so that when someone comes to burglarize you, all you need to do is press one of these little metal plates somewhere, and this thing will start up the webcam, and all the burglar's activities or all the robber's activities will be forever immortalized on the internet. I've thought about doing something like that, by the way, and around my house here, except the crime rate is so low around here, I haven't really thought that I needed such a thing. But it'd be wildlife could do it too. You know, you could key it up for wildlife. Another thing, though, that this type of system will be susceptible to is stray capacitance. So if, for example, if a big bear comes near these metal plates, its body capacitance might trigger this oscillator, and that'll set the microcomputer off. In that case, it's a proximity sensor, not a pressure sensor. That would be how a capacitive proximity sensor would work. But you may not necessarily want that bear to set this microcomputer off. Well, then again, I think it'd be kind of cool to get a photograph of, well, around here it'd be a mountain lion. Photograph of a mountain lion around my house in the middle of the night, set off by this type of device. But really, the way that this kind of thing works as a pressure sensor, that stray capacitance is something you don't want, but there's really no way to avoid it in that configuration. But you can change the configuration a little and get rid of that stray capacitance effect so that the bear can come near your sensor without setting your camera off. And then when you go outside unsuspecting, the bear will eat you. With the capacitive pressure sensor, if it makes that kind of a mistake, it'll save your life. In this case, no such luck. More seriously, this conductive foam in between these two metal plates will cause the resistance between the plates to change if something physically presses on the plates and compresses this foam. That change in resistance goes through a current sensor. The current in this circuit changes because of that change in resistance. That changing current goes through this sensor, which goes on to an analog to digital converter and then to the microcomputer. So, in fact, these two devices, the elastomer type pressure sensor, that's what this conductive foam is called, and the capacitive type pressure sensor are intended for the same purposes. However, a porpoise that comes near these plates without actually compressing them might set this one off. But that won't happen in the case of an elastomer pressure sensor. I guess the trade-off is that an elastomer type pressure sensor might not be quite as sensitive as the capacitive type pressure sensor. But those types of devices more seriously, rather than webcams and grizzly bears and things like that, more seriously, mobile robots can use them to avoid if they bump into something that'll cause them to back up and go in another direction, because the pressure on these plates when they hit that obstruction will send a signal to the microcomputer saying, hey, you hit something. That kind of a thing, a mobile smart robot. Those kind of things are coming. They already exist, but they're a little pricey for most people. Stan Gibilisco signing off for now. Until next time, so long.